Hello everyone. Today in this video, I'm going to be going through another question that was in the grade 11 review. I'm going to be looking at the molarity equation, and this was question number 12 in the review sheet. This equation is going to come up a lot, and although many of you know this equation, I think some of the terminology and the symbols might cause confusion. So let's start off with that, specifically what this quantity means right here. 18.0 capital M. That capital M, when referring to a solution, means (18.0) moles per liter of H2SO4. Simply put, that capital M can be used as a short form for moles per liter. So you will see that very commonly used, so just get used to that symbol there. Let's remind ourselves what molarity is. Molarity is an expression of concentration. Concentration relies on two factors: the solute, which is the chemical substance which is dissolved, and the solvent, which is the substance in which the solute is dissolved. For our purposes, the solvent's always going to be water. So I will never mention that explicitly when I write 1 liter, because that's always talking about water in this course. So concentration relies on two factors and is always expressed as a ratio. Solvent to solute. How much solute is in the solvent? Molarity is expressing concentration in moles of solute in volume of solution. There we go. Concentration can be expressed in many different ways: grams per liter, grams per 100 milliliters, percentage, but molarity is the most common one we use in chemistry, and that's expressed in moles per liter, or moles per volume of solution. The symbols I use in the molarity equation, I use a capital M to represent the concentration molarity, and as always, a lowercase n for moles, and then a capital V for volume. So this equation here, capital M is equal to N over V, or molarity is equal to moles divided by volume. That's the molarity equation. Now, many of you have learned this equation with a capital C. That is totally fine. It doesn't matter. Some people prefer one way, some people prefer the other. If you want to keep using a capital C, that's totally fine with me. I'm set in my ways. I use a capital M, and that's what you're going to see. So let's now take a look at solving this equation. As with solving any equation, we start off by writing out our givens. So look for the quantities. I see, okay, I'm given a concentration. Molarity is equal to 18.0 moles per liter. And I'm asking how much of that solution, what volume, would contain 0.5 moles. So I'm given my moles. So what we need is an equation which relates moles, concentration, and volume. So that's going to be the equation molarity is equal to moles divided by volume. Should include my units here. Now, since this is the first video in solving mathematical equations in this course, a few things to mention. First of all, do not worry about if you solve the problem a different way than I do. Oftentimes, you've been taught a certain way, and that's the way that's stuck with you, and you like to use that. You might use the factor label method. You might sub into values and rearrange the equation. Doesn't matter to me. As long as you can get the answer, and as long as I can follow your steps, that's great. I'll mention a few things that I care about. One, I need to see the units, okay? Second, show me the equation you're working with and substitute the values in. So I'm going to rearrange this equation first by solving for volume, because that's my unknown. Next up, I'm going to substitute my values in. And then we are going to divide these two values and get to a final answer. We can see that the mole quantities will cancel out and we'll be left with a volume in liters. So my volume is 2.78 times 10 to the negative 2 liters, or 0.0278 liters. The next thing that's going to come up here is questions about significant figures. Now, you may have had a grade 11 chemistry teacher who really cared a lot about always expressing your answers with the correct number of significant figures. I'm really not that type of person, especially when it comes to just solving questions on paper. To me, the place where expressing the correct level of precision is very important is with your experimental data. We're not doing any real experiments in this course, and so I don't want to get too caught up on significant figures, okay? What I'm interested in is when you're solving these questions, is it clear to me that you understand what the question's asking and what you're doing here, okay? I'd rather you give me the raw number of significant figures than to be always drawing one of those equation triangles, something like that, and rather than understanding what the formula means, okay? So simply put, for significant figures, don't round off your answers to less precision than the values in the question. And don't give me all the digits in your calculator. Find a happy medium. If I think that you are not expressing enough significant figures or you're expressing too many, I'll just let you know.